Problem 3, I've been conditioned to see overlapping triangles and immediately think about similar triangles. And I can see that that's verified by this statement here. When they tell me D is parallel to BC, that's their way of saying, hey, these triangles are similar because if their bases are parallel, then the rest of the sides also have to be proportional. And you can kind of see I can stretch that out and it will line up perfectly. And that's how I know these things were formed by a dilation and therefore must be similar. So recognizing that fact, whether from the parallel statement or just from seeing enough of these overlapping triangles, should get you in the mode of proportion. All right, that is how you're going to solve this problem. And I think a really good strategy is separating the triangles. You're going to have that small triangle where that side on the left is 3 and the base is 6. Okay, and then you're going to have this corresponding larger triangle. Okay, and I'll write in the sides here. We're actually looking for BC. That's what we're interested in finding. So I'll call it X. And then they don't tell me explicitly how much that side AB is. Nor do they tell me the other side, but they didn't tell me that in the other triangle either. So I'm not worried about the right side, but I can see, hey, that side is really the sum of two pieces. It's the sum of, do it in green. It's the sum of this piece down here and that side in our red triangle. So when we put those two sides together, 2 and 3 with addition, you can see that that side is in fact 5. And that's what I'm going to write, and I'm going to separate this triangle, and I'll bring that X term with me. And now we can start making a proportion. All right, we can compare corresponding parts. There's lots of different proportions you can make, but I'm just going to do it this way. I'm going to compare, I'm going to start with the big triangle and divide it by something from the small triangle. So I'm going to make my equal sign, my ratios, and I'm going to take something from the big, and I'm just going to pick that 5. And I need to divide that by the corresponding piece. Right, corresponding is huge with any similarity or congruence type stuff. And the corresponding piece, that left side, is a 3. And I'm going to repeat that same step with my other ratio. If I start with the big, I got to take another thing from the big. It's got to be X on top, 2 blue pieces on top. And then I need to divide that by the corresponding piece, that corresponding base. So now I've got a true proportion that I can solve. I'll solve with what we've talked about as butterfly multiplying, and that's 3 times x, which is just 3x, and 5 times 6, which is 30. And if I'm solving for x, I'm going to divide both sides by 3. And I can see this simplifies to x equals 10. Before calling it a day, I'm going to just verify that x really was that thing that they were asking for. You know, what I called x, was it really the thing they were looking for? And yes, BC was in fact 10. Okay. I encourage you to find the scale factor. If you're still a little skeptical about this, divide corresponding sides to see the scale factor that took place and then apply that.